Hello, this is Mrs. Thompson at Ben Franklin Middle School. We are starting lesson C1, Simplifying Algebraic Expressions. One thing I do want to point out to you that as we begin this unit, the next 3 units that we are working on are really important. We're going to be working with solving equations, linear relationships, and then functions. After you have taken the tests on C, D, and E, there will be a final exam over all these units. It'll be close to the end of semester 1. There will not be a retake on this, so our hint is don't throw away your books. Keep C, D, E, and to study. So we are going to be looking at some definitions. We are going to be looking at that word coefficient and term today as you are working. We're going to be grouping expressions together as we look at their meanings. We're going to apply the order of operations and the inverse. And we're going to be constructing an argument to justify what we are doing. So as we go through our vocabulary, again, if you need to pause the video, pause it as you can, and go back and fill these in. I'm going to uncover all of our vocabulary so that we can read through them. The distributive property, that's a mathematical property that is used to simplify expressions and equations. When we think of terms, term is one part of an expression, usually separated by the terms with an addition or subtraction sign. We are going to be talking about like terms and combining our like terms. Like terms are variables that are raised to the same power. So if you have a 7x and a 4x, those are the same power. We consider that power to be 1, even though we don't write it there. Whereas if we have a 4x squared, that is a different power. So like terms are going to have the same power for our variables. That next word is coefficient. You're going to hear your teachers refer to this quite a bit. Coefficient is the number that is being multiplied by a variable. So not all terms have a coefficient written in front of them. If there is no coefficient, it's understood to be a 1. So if you look at x, that really means 1x. If you look at a negative x squared, that really means a negative 1x squared. We just usually don't put the 1 in. It's understood to be there. One of the first things as you are looking at this problem of the example of the distributive property and then looking at the terms is that inside this parenthesis we have 2 terms, right? Terms are separated by addition and subtraction. We also have 2 terms back here. When we use that distributive property, that means like your teachers distributing papers in class, is that they are going to hand it out to each row or each column. And so 3 times the 2x gives us 6x, and 3 times the 7 gives us 21. Here we are looking at terms. We have 5x squared. As we are looking at that, we have a plus 3xy, and we have plus 19. We have 4 terms. 1, 2, 3, 4. 2 of them are like terms. These 2 are considered to be our like terms because they both have an xy to the same power. So as we are taking a look at our problems, it's really important that you're understanding those. Again, if I asked you in this problem that was written here, what is the coefficient? If we are looking at the coefficient of x squared, you would tell me 5. If I asked you for the coefficient of xy, well, there's 2 of them. There's a positive 3 and negative 2. So, but when we add our like terms, that's going to come out to be 1. So making sure you're understanding the coefficients and the understanding of that word. Now again, you may want to pause the video as we're doing these. I'm going to do the first couple, and then I'm going to have you do the last 2 and pause the video and try them. As you are taking a look at this, a lot of times I'm going to put these arrows to show that we are multiplying. You are taking 2 times y plus 2 times the 4, which gives us a solution of 2y plus 8. If we're doing this next one, people always get a little worried when they see those fractions. Remember, you are taking 12 times 3, then you have a minus, and you are taking 12 times 1/6 h. Now, 12 times 3, no problem. We are looking at 36. And 12 times a sixth, when you look at that, we are really thinking, oh, this is 12 over 1 6 goes in here once and in here twice, or 12 divided by 6 is 2h as we look at that solution. I would like you to pause the video and to try these next two, and then I'm going to show the work and put the answers up for you. If you did pause the video, sometimes showing those arrows helps as you are drawing what your solution is, showing that it doesn't matter if the 3 is in front or in back, that you are taking it times both items in the parenthesis. If there are more than 2 things in that parenthesis, you have to make sure whatever outside the parenthesis gets multiplied by all of them. So this should be a little bit of review that we are working with here. Here we are going to be asking you to simplify. You're going to see some in your homework like this. So my hint is that when you do the problem, you're going to put each one over the 5. So 3x over 5 can't be simplified. Plus 10 over 5 can be simplified. So we write this as 3x over 5 plus 2 for our solution. I would like you to take a look at this next one, and nothing seems like it's going to simplify, and we are just simply going to write that as 15/7 plus 6m over 7. Remember, keep the variable in your numerator. Here's the one that really confuses students, this multiplication property of -1. Keeping in mind that any number except 0 multiplied by -1 is going to become the opposite. So -1 times -5 gives us +5. -1 times 6 gives us the opposite, -6. So what happens when we have the distributive property? Well, the distributive property makes everything when you have that -1 out in front, and sometimes like this second one, they don't even write -1. They just assume you know that this is -1. So they might not write it, but what it means is that everything inside that parenthesis becomes the opposite. So when you are distributing this, you are taking -1 times 2x, which gives us a -2x, plus you're taking -1 times y. Here you're going to take the -1 times -3 and the -1 times the 4u. When we do that in both cases, what is our solution going to look like? The first one, as we look at that answer, we should have -2x minus y. I often have the question asked, what if I keep it as plus a -y? That would be correct also. Simplified form means that we use the least amount possible, but I do like -2x plus -y as an answer also. So, just be really clear with your teachers and the simplified form that you are looking at. The last part of this lesson, so we're going to be talking about identifying your like terms, and then we are going to do some problems with adding like terms and simplifying on the next 2 pages of your notes. So the key thing is a like term. So we know terms are separated by addition and subtraction. Like terms will have those who have the variables that have the exponents the same. In other words, they are like each other. So keeping in mind where the coefficients are. The coefficient is just the number that's times it, and those can be different. So here I have 1/3 xy squared, -2 xy squared, 6x and y squared, and xy squared divided by 2. So it says all of these are like terms because they have this x squared y. And someone was asking about this one. This really means, right, 1xy squared divided by 2. And some people might write it this way, 1/2 xy squared. Okay? We are not going to be adding or doing anything with those ones, just kind of are defining. What are unlike terms? Well, unlike terms, again, will not have the same variables or powers. So -3xy, -3y, and 12y squared are unlike because none of these are the same. They are all different. Examples of unlike terms because of the variable or their exponent. So sometimes people get these confused thinking, oh, they both have a 2 in front. Again, you're looking at the x and x squared are not the same. The y and xy. Now, I will tell you that if you have something like 2xy and you have a 3yx, these two could be the same. The order of the variables doesn't matter. It just matters that they have the exact same ones when you look at that. So just be careful. On this last page of your notes that you are filling in, you are going to see we have some examples on the top. I'm going to try the first one, the first two, and then I'll have you pause the video and do the last ones. And then we have 4 more problems on the bottom of this page. So first off, when we take a look at this, it says only like terms can be added or subtracted. Here are your steps in order. Identify the coefficients. Remember, coefficient is the number times the variable. Add or subtract the coefficients, then the variable part does not change. This is key. When you add x and x, it does not become x squared. So when I look at this one, I have 3x, 8x, and coefficient in front is a 1. So I am adding 3 plus 8 plus 1, so that when I add those like terms, I get 12, and it stays as an x. If I look at this problem, sometimes we think of it as like reverse distributive property. My coefficients are 5 minus 2, and I keep the m. So my answer is going to be 3m. I would like you to pause the video right now and take a look at these last 3. And again, keep in mind, like I was talking on that last page, terms can have the same variable or last name, but different in their numerical coefficients. So remember, x squared y, those are the same last part. -4 and 7, if we were adding those, would give us 3. So pause the video and try these last ones if you would. This first one, 5 plus 7, if we add those together, gives us 12 and the x squared. Notice mn, we are going to add our coefficients. So we have 9 minus 5, which leaves us with 4. AB, all the same, so we are going to add our coefficients. And again, sometimes that by adding, we do mean subtraction too. We are taking -9 plus 6 plus 5 minus 2, keeping your A and B. Again, if you need to go back or pause this, take a look back over it to make sure you're understanding. The last part that we are going to look at is simplifying. So whenever your teachers ask you to simplify, that means you don't want to have an answer with a parenthesis if you can get rid of it, and you do not want to have like terms, so you want to combine those. So simplified expression, no like terms, no parentheses. This is key. So throughout the year and next year as you get into algebra, no parentheses, no like terms. So pause the video and just try these on your own, and then you're going to see my solutions, but give it a try on your own first. The first one, 2y. The second one going across, -12 m and n to the 4th. When we take a look at this next one, if you've tried it, you have to distribute first. So we have 3x squared, 3 times x squared, plus 3 times 2, which gives us 6, plus 2x squared. Not all of these are like terms. These are my only 2 like terms. Sometimes I'll either circle or I might even highlight ones that look alike because I know I want to keep the plus 6 in my problem. And in this case, when I look at this answer, I have 5x squared plus 6. I look at this last problem and I have 3w plus 5w squared. I don't have like terms. This is w to the first, w to the second. So if this happens in your homework, again, you can tell me it cannot be simplified. As you are taking a look, again, pause this if you need to. Make sure you're understanding these answers. Your homework is only this one page. You are going to be doing this tonight before you come back into class. So show the distributive property. Make sure as you're showing that distributive property, remember that you are trying to eliminate parentheses. That means to simplify and add like terms. This, again, take a look at your notes. We did this on that second page of your notes. We're writing it as a fraction over the one denominator. And then the last problems, you are asked first to use that -1. So again, you're distributing. And then as you finish, you are going to be combining like terms. Be sure you check your answers in the back. So make sure you're on the right track with these. You do not want to do them wrong. Do one, check it, make sure you're on the right track. Have a great day, and we'll see you in class.